Hello, this is Professor Broker, and this is your Chapter 7 and 8, Lecture 1, Part 1, titled Welfare Economics. So let's go ahead and get started. Okay, now when we talk about the allocation of resources, okay, we've been referring to how much quantity is produced, what price clears the market, these types of things, which producers produce it, which consumers consume it. But we really haven't studied how the allocation of resources, a specific quantity and a specific price in a market, how that affects economic well-being. So we need another tool, okay, to be able to sort of do that analysis. And that the tool we're going to develop in Chapter 7 and then apply in Chapter 8 is called welfare economics. Now, when we talk about welfare economics, we are not talking about welfare like to low-income individuals from the federal or state government, the SNAP program, food stamps, these type. We're not talking about those programs. This is a different thing entirely, and so I don't want you to get confused when we say welfare economics. Okay, what we're talking about is economically speaking, economic well-being from the allocation of resources in a market. Now, first we're going to look at the demand side of the market, okay, and how they're affected by the price and quantity in the market. And then we're going to look at the supply side. To look at the demand side, we need to look at how buyers value a given good or service. To measure how they value it, we're going to look at a concept called willingness to pay. How much is a buyer willing to pay, okay, for a good or service? Okay, let's look at an example where we have four individuals: Anthony, Chad, Flea, and John. Okay, and they each have a different willingness to pay for, say, an iPod, right? Anthony is willing to pay $250, right? Chad is only willing to pay $175. So obviously Anthony values the iPod more than Chad does, right? And then Flea and John and so on. Okay, now from these willingness to pay, we will be able to derive a demand curve. Let's see how, right? So if the price of an iPod is $200, let's say, who logically will buy the iPod, right? Well, Anthony values the iPod at $250. So at a price of $200, that's less than what he is willing to pay. So of course he would, right? If I go into the store and I'm willing to pay $100, but the price of the good is only $50, of course I would be willing to pay less, than my maximum. Okay, I would be better off in that sense. And so Anthony would be willing to pay. Chad values the iPod less than $200, so he wouldn't pay. He wouldn't buy it. Flea values it more than $200 at $300, so he would buy. John would not buy it, right? So we would have a quantity demanded of two iPods at a price of $200 based on these four consumers. And we know exactly who would buy them too, right? It would be Anthony and Flea. Okay. Now, so let's go ahead and with a range of prices, let's go ahead and try to fill in this demand schedule based on these valuations. So if the price is above $300, who would buy the iPod? Well, the answer is nobody, right? Because nobody values the iPod more than $300, and so our quantity demanded would be zero. At a price range between $251 and $300, we would get Flea, right? Flea values the iPod in that range, so we would have a quantity demanded of 1. As the price continues to fall, we would obviously still have Flea. Flea would, of course, be willing to pay a lower price between $176 and $250, but then who else would we get? Well, we would get Anthony, wouldn't we? Because Anthony values the iPod in that range at $250. So our quantity demanded would be 2. As the price continues to fall, who would we add to the group? Who would all of a sudden jump into the market as our marginal buyer? Well, of course, we would get Chad, right? Chad values the product at $175, so as the price falls below $175, between $126 and $175, he would be willing to demand the product at that point, so our quantity demanded would be 3, and as the price falls below $125, obviously we would get John, and then our quantity demanded would be 4. Notice, from these willingness to pay numbers, we are able to derive a demand schedule which obeys the law of demand, right? As the price went down, notice our quantity demanded went up. Now we can graph this demand schedule, right? And so for prices above 300, notice that we would have no quantity demanded because nobody in our group, in our market right now, values the product that highly. Okay, but as the price drops below 300, okay, we gain our first consumer, right? Okay, and so we have that notch over there, and then we don't gain our second consumer until we get a price below 250. Okay, that's the reason for this stair step of the demand curve, right? And then we don't get our second buyer until, or I'm sorry, our third buyer until the price drops below 175, right? And then we get our third and then our fourth buyer finally when the price drops below 125. And so we're basically just graphing over here on the graph this demand schedule that we derive from our willingness to pay numbers. Okay. Now, it may seem odd that this is a stair-step shape. You say this can't possibly be a demand curve because the demand curves we've looked at have all been linear, downward sloping lines, and that's true. It looks like a stair-step because we only have basically 4 buyers. We have a very limited number of buyers, and each buyer is represented as one notch there on the x-axis. If this were a truly competitive market, there would be lots of buyers. Okay, I mean hundreds, thousands, maybe even millions. And so these little tiny stair steps would exist, but they'd be so small that you couldn't see them if you really tried to graph a true competitive demand curve. And that's why we just assume a linear demand curve in those cases. Okay, so really what we're doing here is we're just kind of zooming in with a microscope and looking at our demand curve through a microscope and zooming in. But really, in a competitive sense, we really want to zoom out, right, and then the demand curve would be smooth. Okay, so don't let that bother you too much that it's a stair step. Okay. Now, what's important to notice here is that at any height on the demand curve, that point on the demand curve represents a marginal buyer, right? And so, for example, this portion on the demand curve up here, that literally represents Flea's willingness to pay. I mean, it's a literal buyer represented physically on the demand curve, right? And then as we go down the demand curve, we gain Anthony. As the price falls, then as the price continues to fall, we gain Chad, and that's represented at that specific point on the demand curve. And then we finally gain John, right? And so it's important from this point moving forward, when you look at the demand curve, to realize that each individual point along the demand curve represents an extra buyer. And as the price falls, we gain a marginal buyer, and as the price increases, we lose marginal buyers. Okay. Now we need to understand consumer surplus, which is going to be our first sort of measure of, understanding this welfare economics idea. Consumer surplus is simply how much buyers gain from being in a market. And we're going to measure it as their value of the product, okay, or their willingness to pay minus the price they actually have to pay, right? So if I go into a store and I value something at $100, right, and I only have to pay $50 though, because that's what the price is, then obviously I am $50 better off. That would be my consumer surplus, my willingness to pay minus the price I actually have to pay. Also recognize that if I go into the store and my willingness to pay is $100 and the price is $150, okay, well, my consumer surplus would not be 50 in that case, right? In fact, it would be a negative 50, and a negative consumer surplus means I actually would not buy the product, and so my consumer surplus would actually be 0. Because if I'm rational, which we're assuming people are, and I really do value something only at $100, I'm not going to pay $150 for it, and so I would not buy the product in that sense. Okay, so let's try to calculate some consumer surplus, assuming in this market, again, with Anthony, Chad, Flea, and John, assuming a price of $260. Okay, well, obviously, Flea would purchase the product, and he would have a consumer surplus of 40, right? And there would actually be no other consumer surplus because nobody else values the product at a price of or no one else values it at $260 or greater other than Flea, and so that would be the total consumer surplus in this market. At a price of $260, there would be a quantity demanded of 1, and the consumer surplus would be $40, 300 minus 260. Okay? Graphically, we can see that here, okay, that if we go to a price of $260, draw a horizontal line across to the demand curve, everything below the demand curve and above that price would represent our consumer surplus. Again, you can think about it visually and relate it to the math, right? The demand curve represents visually our willingness to pay of our consumers, which we need to subtract the price from. And so again, everything between the demand curve, the willingness to pay, minus the price, the blue line, that that gap there, the difference between those two things, should be our consumer surplus, both mathematically and also graphically. Okay, and so that's why, boom, right there, that in this case, rectangle, it won't always be a rectangle, but in this case, the rectangle represents our $40 consumer surplus at a price of $260. Now, what happens if we lower the price to $220? Okay, well, don't we gain a marginal buyer? Well, sure, right? We gain Anthony, right? First of all, Flea would still buy the product. Flea would buy it. He values it at $300. He's only going to have to pay $220, so his consumer surplus would be $300 minus $220, or $80. But we also gain Anthony, right, who values the product more than $220. So his willingness to pay $250 minus $220 would be a $30 consumer surplus. So the total market consumer surplus at $220 would be the $80 plus the $30, and then of course John and Chad both have zero consumer surplus because they don't buy the product, because they don't value it that highly. So the total consumer surplus would be $110, the $80 plus the $30. Graphically, we would draw a horizontal line at a price of $220 over to the demand curve. Everything below the demand curve, below the willingness to pay of the buyers, and above the price would represent our consumer surplus. In this case, it's just going to be two rectangles, and so we can divide it up that way, right? Here is Flea's consumer surplus. It would be the 300 minus the 220 times 1 would be that rectangle of 80, and then the other rectangle would be Anthony, and it would be simply the red line 250 minus the blue line of 220 times 1. And that would give us 30. And so then both rectangles together would be the 110 consumer surplus. And again, the important thing here is to realize that total consumer surplus equals the area under the demand curve and above the price, from quantity 0 to whatever the positive quantity is. Okay, so basically in the first quadrant, okay, using the X and Y axis as our barriers there, everything above price but below demand curve would represent our consumer surplus in the market. Okay. Now let's apply the same analysis to a market with a smooth demand curve with lots of buyers. Okay, we're looking at the market for shoes. Okay, the y-axis is the price per pair. The quantity or the x-axis is 1,000 pairs of shoes. Okay, or our quantity. Here's our demand curve. The y-intercept is $60 and it's downward sloping. Okay. The first thing I want to say is, at a quantity, at the 5,000th quantity, or we'll just say 5, what is that marginal buyer's willingness to pay? Well, to find that, you go to 5 and you take it up to the demand curve, right? And at that point on the demand curve, whatever the price is, okay, that is that marginal buyer's willingness to pay. Because remember, each individual point on the demand curve represents a marginal buyer, and so that the 5,000th or the 5th marginal buyer has a willingness to pay of $50 per pair of shoes. So if the price was $30, that specific buyer would obviously have a consumer surplus of $20. The 50 minus the 30, right, and $20. That specific buyer, that's not our total consumer surplus, but that would be the marginal buyer's consumer surplus, the 5th marginal buyer's consumer surplus, right? So now let's just say that the price is 30. Okay, what would be total consumer surplus in this market? Well, remember, it would be everything below demand, below the demand curve, but above that $30 price. Okay, and then using our y-axis there as a barrier. Obviously, what shape does that make? Well, that makes a triangle. Okay, and how do you find the area of a triangle? Well, you find it as base times height divided by 2, right? Base times height divided by 2. So we would simply apply the exact same analysis here. Okay? Okay, and so what would be, again, it doesn't really matter which area you want to call your base or your height. So let's just call this distance right here your height. The 60 minus the 30, okay, obviously is a height of 30. Okay, the base would be the quantity, so 0 to 15, or obviously 15. So 30 times 15 divided by 2, or times 1/2, would be 225. Now, of course, this would be in thousands, so it would really be $225,000. And what does that represent? It's, first of all, in dollars. That's important. It's measured in dollars. It's a dollar amount. And what does that measure? It measures the dollar value created in this market for buyers participating in the market at that price. So at a quantity of 15,000 at a price of 30, okay, for buyers, for the given demand in this market, buyers are benefiting, not just by getting the shoes, but by getting the shoes at that price, they're benefiting by $225,000. Okay, and that's what that's telling us. Okay, that's how much better off these consumers are. Okay. Now, the price isn't going to remain stagnant though, right? Prices can change. So what happens, for example, if the price goes up? Okay, well, what would happen, say, to 40? Okay, well, buyers would obviously be worse off. Now, how could the price go up to 40? Well, imagine if there was a supply curve there and the supply curve decreased, right? That would obviously raise the price. So for some reason, maybe there were some factory closures or something like that, or maybe there was input cost increases, but somehow, some way, supply decreased, right? And that would obviously raise the price. How would that affect consumer surplus? Well, it would decrease it. And it would decrease it for two reasons, right? Our new consumer surplus would only be $100, right? Because it would be the 60 minus the 40, or 20, times 10, which would be 200, divided by 2, which would be $100. Consumer surplus has gone down, and it's gone down for two reasons. One reason it would go down is because some marginal buyers would leave the market. Okay, represented by this small triangle there. They don't value the shoes at $40. They value the shoes at something less than $40, and so they're not going to be willing to pay that higher price. So they don't buy the shoes. They effectively leave the market. So we lose that consumer surplus. But we also lose the consumer surplus of the buyers who stay in the market. They stay in the market. They still buy the shoes because they value the shoes at more than $40, but obviously they were better off when the price was lower, right? And so because of the higher price, that cuts into their consumer surplus. So total consumer surplus has gone down for both of those reasons.